Okay everyone, Dave here. This little mini lecture's on what makes a strong acid or a base. So we're going to have a bit of a think about what a strong acid and a weak acid and a strong base and a weak base actually look like. Now, if you recall in a previous mini lecture, I showed you an equation that looks something like this, where we have an acid, in this case it's HCl. Let me get my pen here, and it reacts with a base. And instead, if we haven't named a particular base, we assume it's water. It gives up a proton to water and it produces this hydronium ion here and of course chloride ion over here. And I also said to you that the back reaction can occur, and that is that the hydronium ion can give up a proton to this chloride ion, in which case it's an acid. In fact, I'll just write A here for acid, and the chloride ion's the base, and this is the acid, and this is the base here. So, as I explained, this reaction can go backwards and forwards like this, but it doesn't mean that you've got 50% of this stuff and 50% of this stuff here. How far it actually goes to the right or the left is going to depend on how strong the acids and the bases are. So if you look here at HCl, it's actually regarded as quite a strong acid. So this brings me to the definition of what a strong acid is, and it's something that really likes giving up protons easily. So A has a very high tendency to give up HCl has got a very high tendency to give up protons. Implicit in that is, if something has a high tendency to give up protons, obviously there are things that have high or low tendencies to accept protons, and so therefore a strong base is something that's very good at accepting protons, and a weak base is something that's not particularly good at accepting protons. So how far a reaction goes this way is going to depend not only on how strong the acid is, but on how strong the base is. Now, it just so happens that water isn't a particularly strong base, but HCl is a very strong acid. So the reaction tends to go very much in this direction, because this acid here is actually quite a weak acid, so we don't get much reaction going back in that direction. Alright, so there's our definitions. A strong acid is a compound that has a large tendency to transfer a proton to another molecule. A strong base is a compound that has a large affinity for protons. Now, this next point is an extremely important one, and I've just sort of touched on it then. If you want to compare the strength of respective acids, there's no point taking different bases with different strengths and seeing how protons are transferred from an acid to these different bases. You've got to compare how an acid or a number of acids transfer a proton to just one base. And the base that we define as the standard in all this is again water. And so we can actually then work out some numbers to indicate how strong acids are. So if we look at this next table here, we've got the names of these acids here. We start up here, we've got this one called carbonic acid. This is actually the weakest acid in the list, and the number is referred to as the pKa. Now, I'm not going to go into the details about how that pKa is calculated, but basically the larger the pKa, the weaker the acid, and the smaller the pKa, the stronger the acid. So you can see here as you go up the list, the numbers get progressively smaller, and so the acids get progressively stronger. Now, I know you've got to kind of think in reverse to remember that, but nevertheless, that's the way it goes. So you can see here we've got acetic acid that's present in vinegar, its pKa is 4.75. Citric acid present in particular fruits like lemons, its pKa is 3.13. And then we take a big jump. These three here, let's grab my red pen, these three here I'd regard as being weak acids. And again, how do we compare them? Only because of their ability to give up protons to water. But these guys here are in a different ballpark altogether. They are strong acids. So sulfuric acid is a strong acid. You can dissolve a lot of things in sulfuric acid. It's extremely reactive and nasty, and HCl's not that much better. Okay, that's it for this particular mini lecture.